All right, so the first section here in Chapter 8, it's pretty evident that we're going to shift gears from talking about triangles to talking about polygons in general. Okay, and you're already familiar with polygons. You already know the names of certain polygons, i.e. triangle, quadrilateral, pentagon, hexagon, so on and so forth. So the goal today is very simply that we're going to look at angle measures inside of polygons. And when we do this, when we're trying to find the sum of the interior angles of a polygon, we're actually going to use something we already know. Okay? And the thing that we do already know is the interior angles sum of a triangle. So what we're going to do is we're going to use triangles to understand this idea of the interior angle measures. Okay? So we're going to cut all of our shapes into triangles. Obviously, the first one where n equals 3, in other words, the number of sides is 3, it's a triangle. There's only one triangle there. This quadrilateral, I can cut into two triangles by going diagonally across from the two opposite vertices. The pentagon, I can cut into 3 triangles. And obviously, these triangles, you notice there's no intersections inside the figure. The lines that I'm drawing are strictly going from one vertex to another vertex. Okay, and finally, the hexagon here can be cut into, let's see here, 1, 2, 3 lines there, and we have 1, 2, 3, 4 triangles in a hexagon. And so, if you notice, when the figure had 3 sides, there was 1 triangle. When the figure had 4, there was 2. When the figure had 5, there was 3. 6, there was 4. Common relationship there. If the number of sides you have minus 2 is the number of triangles you can create. Okay? And so that's exactly the formula that we're going to use. Okay? The sum of all the angles of a polygon is given by the formula n minus 2 times 180, okay? Or really, let me actually rewrite this. In this spot, what we'll say, and this is just so we're being consistent throughout our notes, we're going to say it's the number of triangles times 180. And now, as I said already, we know that the number of triangles is given by the expression n minus 2 times 180. So this formula right here is the big one. That's the one you need to memorize. That's the one you have to know. N minus 2 times 180, where n is the number of sides. So again, this is just saying that same theorem over again. Okay, n minus 2 times 180 degrees. So it says, what is the sum of the measures of the interior angles of a quadrilateral? Well, in a quadrilateral, the number of sides is 4, and so I use my formula n minus 2 times 180. So when I plug in 4, I get 4 minus 2 times 180. That's 2 times 180, and that's 360 degrees. Okay, so I know that the angles inside of a quadrilateral, no matter what kind of quadrilateral it is, square, rectangle, rhombus, parallelogram, trapezoid, doesn't matter, they will always add up to 360 degrees. Again, this is the sum of the interior angles. That's what this formula gives you. Okay, find the sum of the measures of the interior angles of each convex polygon. All right, so the first thing is, you know when it says find the sum, I'm thinking n minus 2 times 180. Got to identify n. There's 1, 2, 3, 4, 5, 6 sides. So I have 6 minus 2 times 180. That's 4 times 180. And 4 times 180 is very simply going to be 720 degrees will be the sum of these interior angles here of this hexagon. Every 6-sided figure will have an interior angle sum of 720 degrees. Again, my suggestion now would be to pause the video, see if you have this. But again, if not, then interior angle sum, n minus 2 times 180. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's a decagon. And so, again, my n is just 10 now. So I have 10 minus 2 times 180. That's 8 times 180. and 8 times 180 is, I believe, 1440. Let me just grab a calculator to verify that my mental math is accurate. Let's see here. 8 times 180 is, in fact, 1440 degrees. Okay? So there you have it. Interior angle sum, n minus 2 times 180. Got to memorize that formula. So this is kind of working backwards now. It says the sum of the measures of the interior angles of a polygon is 1260. Classify the polygon by the number of sides. Well, I see sum of interior angles. So immediately I'm thinking n minus 2 times 180. And what they've done now is they're not asking us to find the sum. They give us the sum. They tell us that this is equal to 1260. Find the number of sides. In other words, find n. Okay, so I go through and I solve this. It's pretty simple. It's an algebraic equation now. Divide both sides by 180. So on this side I have n minus 2 equals 1260 divided by 180 is 7. Add your 2 to both sides, and so we know that this figure is a nine-sided shape, and it says classify it. If n is 9, then my figure is a nonagon. Okay, remember the name of the 9-sided polygon is a nonagon. Again, I think that's pretty straightforward, but again, just working backwards, working the other way. Okay, still using the same idea though. All right, again, check yourself right now. Pause the video, see if you have this. So n minus 2 times 180 is 1620. Cancels there. So n minus 2 equals 1620 divided by 180 is 9. Add 11. Add 11. N equals 11. I'm sorry, add 2. Look at me. I'm already jumping. I'm thinking one thing, saying another. Add 2. N equals 11. And 11-side figure is just very simply an 11gon. Okay? Just an 11gon. So, again, pretty straightforward examples. Hopefully you're catching on pretty quick here. All right, now I'm going to extend this a little bit more, and I'm going to use this idea to solve for the value of x. So the first thing I have to do is identify what do these angles have to add up to. Okay, so I have n minus 2 times 180. In this figure, there's 1, 2, 3, 4 sides, so I know I have 4 minus 2 times 180. That's 2 times 180, which is 360. So this number is what all 4 of these angles have to add up to. So now it becomes an algebra problem. X plus 71 plus 112 plus 135 equals 360. Sorry about that 3, it's pretty ugly. And so on the left-hand side, when I add 71, 112, and 135, I get 318. So I have x plus 318 equals 360. Subtract 318 from both sides. And you'll notice here that the value of x in this diagram is 360 minus 318, which is 42. All right. So again, using the interior angle sum theorem to find the interior angle sum and then set up an algebraic equation and solving. Okay, so now this diagram is a little bit different. Again, obviously 1, 2, 3, 4, 5 sides. So immediately I know I can do, I don't have to rewrite the formula here again. We know the formula now. Okay, so I have 5 minus 2 times 180. That's 3 times 180. 3 times 180, I believe, is 540. That tells me all these angles add up to 540, and you're saying, well, wait a second, there's 2 of them I don't know. Yeah, but we know that those 2 angles are also the same measure. So if this guy's x, this one also has to be x if they're the same. So now when I set up this equation, I have 68 plus 105 plus 109 plus x equals 540. So on the left-hand side, I get 2x plus, let's see here, 109, 105, and 68 makes 282. Subtract that 282 from both sides, and I get, let's see here, 2x equals 540 minus 282, which is 258. Divide both sides by 2. X equals, let's see, 129. So each angle measure there, each of the missing angles is going to be 129 degrees. Again, same theorem, just a different way of applying it to solve in a given polygon. And the last big idea we're going to talk about in this section, which is a very simple idea, is that the exterior angles, in other words, the angles outside of the polygon, and you'll notice in order to see these angles, you have to take your side lengths and just extend them out, going in the same direction every time. Okay? That's the only way this is going to work. And so the interesting thing here is that the exterior angles add up to 360. No matter how many sides there are, the exterior angles will always add up to 360 degrees. Okay? And so we're going to use this to solve various problems. So again, this is a pretty basic one, right? So given this polygon and the exterior angles, I know that x plus 89 plus 2x plus 85 has to add up to 360. So I get 3x plus 174 equals 360. Subtract my 174 from both sides, so I end up with 3x equals, let's see here, that's going to be, I believe, 186. Let me just, I don't want to make any mistakes here, so it is 186. Divide both sides by 3 to get x by itself. X equals 186 divided by 3, which is 62. Okay, and that's all it said to do is find the value of x. Well, there's the value of x, 62 degrees. Add them up, set them equal to 360, exterior angles. Okay, now this one is kind of, we're going to use both theorems that we've talked about in a different way here. So it says find the measure of each interior angle of a regular, remember regular means all interior angles and all side lengths are congruent, of a 15-gon. So the process here is pretty simple. Well, I shouldn't say pretty simple. It's actually a little bit more complex than the ones we've looked at. It says find the measure of each interior angle. Well, the first thing I have to do is figure out what do these interior angles have to add up to. So I use my interior angle sum theorem. We all know 15 minus 2 is 13. 13 times 180 is 2340. So that's what all my angles have to add up to. So now hopefully this makes sense. If that's what my angles have to add up to, and I have 15, right? I have 15 angles and they're all the same exact measure, then hopefully it makes sense that the measure of one of them will be 2340 divided by 15. 2340 divided by 15 is 156 degrees. That would be the measure of each interior angle of a regular 15-gon. Okay. The second part says find the measure of each exterior angle. Well, again, each exterior angle is going to be congruent, and there's 15 of them. And this is even easier because we know exterior, 360. There's 15 of them. Divide by 15. Each exterior angle has to be 24 degrees. All right, again, still using exterior angle theorem, the sum theorem, but in a slightly different capacity. It says a convex pentagon has exterior angles with measures 66, 77, 82, and 62. What is the measure of an exterior angle at the fifth vertex? Again, exterior, they have to add up to 360. I already know 4 of them. I know 66, 77, 82, and 62. I got to find the fifth one. We don't know it, call it x. All right, and now again, it's just a very simple algebra problem now. 66, 77, 82, and 62 all add up to 287. So I have 287, 7, plus x equals 360, minus this 287 from both sides. And I'm pretty sure we're going to end up at the last exterior angle there has to be 73 degrees. All right, so again, hopefully this interior exterior angle sum theorems are starting to click a little bit, and if not, we'll take questions on it in class and make sure that you're all comfortable and good to go. All right, so again, here's another example for you to take a look at. I'm going to go ahead and let you guys take a look at that. We've done plenty of examples now, and I'm hoping that you're good to go here. So this is a good test for you to see where you're at.